Today is our last section of volume, and we're going to be looking at our three final three-dimensional shapes. We're talking about pyramids and cones today. So pyramids and cones are 3D shapes that have a specific base shape and come up to a point. Now, the three bases we're going to be talking about is the square, the triangle, and the circle. So if you think about those two-dimensional shapes, so obviously we have our square, we have a triangle, and when we're talking about these triangles today, we're talking about right triangles. So I'll go ahead and show it like that, and there's a right angle and the circle. Okay, so each of them kind of has their center-ish, and so that's in 2 dimension. What we want to look at is the 3-dimensional shape, so pyramids and cones. So all of these are the base shape of our 3D shapes, and they're going to come up to a point. So the way we show that, obviously we can't see a square directly like this because that's like looking above a pyramid, like the ones in Egypt. Looking straight from above, we would see this shape right here. But we want to see this kind of from the side. So if you want to practice your 3D drawing right here, there's a square, but looking at it from an angle, and then there's a point up here that everything's going to come up to. Okay, and there we go. We've got our 3D pyramid. So that's with the square base. With the triangle base, kind of the same thing. We have our right triangle here. It's a little bit slanted because we're looking at it from an angle, and then everything's going to come up here to a point. And that one's in the back because behind it. And then a circle, we want to slant our circle a little bit, make it more of an oval, but there we go, we've got a cone shape. Alright, so the ones on the left are pyramids. Technically, the one on the right is called a cone. All of them are pyramids technically, but when it does have a circle base, we call it a cone. All right. So let's look at the specific formulas for all these volume shapes. All right. So first one, the volume of a square-based pyramid. Okay. So I'm going to write it like this. So the volume of the square-based pyramid is, and you'll see properties from the area in these equations. It is fancy L, that's length times width times height, but then the whole thing divided by 3. All right, and so when we're talking about length and width, they're talking about the base. So that is the length of the base. W is width of the base. Because if we just met our multiplied length and width, that would give us the area. But then we need to give it some dimension there of height. Okay, so there you go. Volume of a square-based pyramid. All right. So moving on. Volume of a triangle-based pyramid. So the base of the other one was a square. The base of this one's going to be that right triangle shape. So the volume of the triangle-based pyramid, I'll just put it like that. So very similar. It's going to be L times W times H, length, width, height, but this time it's going to be divided by 6. All right, so same kind of setup. Length, width, height. And finally, the last one. I made the note down here. It's the volume of a cone, or if you really want to think about it, it's a circle-based pyramid. But remember, circles and other stuff. So the volume of a cone, this one definitely has pi in it anytime we have something round or circular. So pi r squared, remember that's the area of a circle, and then we add some height to it, but that's just a cylinder there. But then we've got to divide it by 3 because there's a little bit less than what an actual cylinder would be. So remember, that's pi. R stands for radius, and H is height. Okay, so there's the three formulas that we're going to be using today. Mainly I'm just kind of concerned that we can plug the numbers in and get the right units. And remember, all these units are in volume, so they have to be cubed, okay, depending on what they give us. All right, so for example, let's go ahead and find the volume of the following 3D shape. So we're going to draw this out. Okay, so they give us that right there is 4 inches. There's a point right here. Go straight up, and they tell us that that is 10 inches. Okay, so they want us to find the volume. We're dealing with 3 different shapes today, so the first thing you want to do is figure out which shape this is. Obviously it is a pyramid, but we got to look at the base shape down here. Let's see, 4-sided shape, it's a square-based pyramid. All right, so we're trying to find the volume of the square-based pyramid, and that equation is length times width times height over 3. Now let's see what we're given. I see right offhand 10 inches there, and that indicates this little mark from the bottom to the top. That is the height. So we have the height. Down here, we've got 4 inches, and we're talking about the base. So that's indicating from there to there is 4. You can call that the length. You can call that the width. We'll call that the length. Now, do they give us a width here? Okay. They don't have a number there, but think about this. That base shape is a square, and squares have 4 sides that are the same. So if this side is 4 inches, this side is 4 inches, the back one's 4 inches, and the left side is 4 inches. So we do have the length and the width, they just didn't label everything for us. So if you want to write it over here, we have the height, we have the width, we have the length, and that's everything we need to plug it in. So length is 4, width is 4, and height is 10. And then divide the whole thing by 3. So doing all the math on this, 4 times 4 is 16. 16 times 10 is 160 divided by 3, or the volume of this square-based pyramid comes out to a 53.3. And then units are inches, but volume always needs to be cubed. Okay, hopefully I said cubed earlier. I might have said squared. Cubed, please, cubed. All right, let's look at another one. So for example, let's go ahead and find the volume of the following. I can do better. All right, and so just taking a look at this, you notice the base of this one is the right triangle. And they'll give us some more information on here. We got a center, goes up to the tip, oh, a little slanted. All right, numbers. They tell us that that side is 3 centimeters. This side is 5 centimeters. That one's 4. And that blue one right there, another 5. Okay, so we see the base. It's a square-based pyramid. Square-based pyramid. So we're trying to find the, or sorry, not square, a triangle-based pyramid. We're trying to find the volume of a triangle-based pyramid, and that equation is length times width times height over 6. So we need 3 numbers to plug in, but I look at it and there's 4 altogether. So something's actually extra. All right. This is kind of going to go against what we've done previously in the past, but just bear with me here. So height's easy. Height is this one right here, how tall the shape is. So that one is 5 centimeters. Now we're looking for length and width, and I'm going to redraw this triangle kind of just in 2D here. So we've got a 3, a 4, and a 5. We want the length and the width of this triangle. If I was finding the area, we actually don't use that 5 on the base. We use the 3 and the 4. So length and width, however you want to set it up. So we're actually not using this 5 down here. We want the 3, and I'll use that as the length, and we want the 4 as the width. So we actually had a little bit of extra here. So don't use the hypotenuse. Looks like we don't use the hypotenuse for these ones. So let's plug it in. We've got a length of 3, width of 4, height of 5, divide the whole thing by 6. So 3 times 4 is 12, 12 times 5 is 60 over 6. So the volume of this triangle-based pyramid, 60 divided by 6 is 10, and the units are centimeters cubed because this is a volume problem. All right. One last example. We've seen square-based pyramids, triangle-based pyramids, so let's look at the circle-based pyramid, which is known as a cone. So we've got this. We can draw it upside down like so. Okay, so that's kind of how we see cones, like an ice cream cone. Give us that there. Give us that, and they give us that. Okay. So they tell me this line here is 17 miles, so this is a pretty big cone. They tell us that is 14 miles. So we look back at our volume of a cone equation. That's going to be pi r squared h over 3. So pi is the number on our calculator. I need the radius, I need the height. Height's pretty easy. This is 17 miles tall. Okay, so height's there. I need radius. The 14 though is not the radius. The 14 is the diameter. If I want the radius, I have to cut that in half. So the radius is actually 7 miles, and that's the radius I'm going to plug in there. So now I do have all my information. Let's go ahead and plug it in. So pi, radius is 7, but it needs to be squared. Height is 17. Divide the whole thing by 3. Alright, so this one needs a little bit more math. I've got pi. 7 squared is 49. 17 still there. I would go to the calculator now, multiply pi, 49, and 17 together, and you get 2,616.9 over 3. And then finally divide that number by 3, and you get 872.3, and then units, miles cubed, because this is a volume problem. So we're looking at how much fills inside of that cone.